You'll see this on the worksheet that I handed out too. So I guess the main thing with tan is that you need a point for reference as well, that point for scale kind of thing for amplitude. So you'll find that unless you've been given an endpoint which allows you to determine the scale, you'll be given one. As you can see, I've got one here which is pi on 6, 3. Now, this is actually two periods that have been graphed here, aren't they? Yes, they are, because remember the period for tan is just pi. So this has got a 2 period here. And we've basically followed through a very similar process, but not quite the same, by basically just picking a value and trying to work out what we can work out. So you can see the question here is just worded slightly differently. I did that on purpose. Given that y equals a tan b outside of x plus c plus d. Now, I deliberately chose different letters here that shouldn't throw you at this level of mathematics. Yes, it should be. My bad. Not that one either. Please hold. Wasn't an opportunity or an invitation to talk, peoples. My bad. So this is the graph that you just saw. Okay, but the sketch obviously doesn't do it justice compared to the lovely all in proportion graph that you just saw, but it's just so you can see it. So here it is here, given that y equals a tan b outside of x plus c plus d. Now, again, at this level of maths, you should not be put off by the fact I'm using different letters, like a C inside instead of a C being at the end, that kind of thing. Don't let it throw you. It's the position. In front of the tan here is the amplitude. In front of the x plus c is the period, well, the thing that will give me the period. The plus c is the phase shift. The plus d is the vertical shift. So we just need to be conscious of all of those things, and we need to figure things out as we go along. So here we go. Again, the order in which we do things may vary, but I am going to start off by looking at the center. So the center is at y equals 1. Okay? So therefore, d is equal to 1. Does that make sense? The graph has been lifted up by 1 unit. So therefore, d is equal to 1. I can see the center clearly because it's marked off on the x-axis and on the y-axis, and I can see that the center's here. It's the visual thing. I don't know how else to explain it. Are we okay? Are we all feeling emotional? Hopefully it's excitement, not sadness. Okay, so the next thing to look at is look for the first middle, like as I keep on trying to tell you, like you've got these up waves here and these down waves here. So there's a middle here, even though I haven't drawn the rest of it, that is still a middle, middle, middle. So the first middle is here, right? Right, bangs back on 0. Okay, so what we do is we just go something along the lines of the first middle between the two halves of that line is at x equals 0. Therefore, c is equal to 0. Okay, so effectively, we've got no phase shift, right? Because we looked at our first x coordinate of a center. It's like you said, Pip. If we talk about this as being just the center or centers of the graph, then we've got a y coordinate and an x coordinate. So we've got a y coordinate of 1, which gives us our value of our vertical shift, which in this case is d. And our x coordinate, which is 0, means that we've got a value of c, the phase shift, as being 0, i.e. there is no phase shift. Charlie, question or are you just stretching? Yep, cool. Okay, so that's our center and our middle, or whatever. We're now going to work out the period. So pretty similar, but this time to work out the period, we are going to go from asymptote to asymptote for the length, right? Asymptote to asymptote. So we're going to go pi, which is the furthest asymptote, minus pi on 3, which is the next one down, and that gives me 2 pi on 3. That's the period But we also know for tan that the period calculation is pi over n, or in this case, pi over b. So pi over b is equal to 2 pi on 3. Switch places, and we get b is equal to pi multiplied by 3 on 2 pi, which will give us a value of 3 on 2 for b. Or you could write 1.5 if you prefer. Is that okay? All right, that's the period done. Now, what letter are we missing? A? A. Yep, A. So there's only also one piece of information we haven't used, and that is this point for scale. So unsurprisingly, the point for scale, the point that gives us our stretch, is also the point that we're going to use. So we literally write in the point and we substitute in. So at pi on 6 comma 3, 3 is equal to a tan of 3 on 2 outside of pi on 6, because there's no value for b, plus 1. So I've done a straight substitution with all the values I know so far. Good so far? Okay, simplifying, subtract 1 from both sides, I get 2. And simplifying the inside, I get 3 goes into 6 twice, I get pi on 4. Oh, isn't that nice? Because we know what the tan of pi on 4 is, right? Starts with O and ends in E, and the middle letter is N. Yeah, 1. So that means that 2 is equal to A. It's not always that nice, but in this case, because I was allowed to make it up for myself, I made it easy for myself. Good so far? The last is just to chuck it all together. So therefore, y is equal to 2 tan 3 on 2x, or you could write 3x on 2, or you could write 1.5x, whatever floats your boat, plus 1. And that is our equation. We'll see it over here. There is the function. 2 tan 3.5 or 1.5x plus 1. And that's it. Anybody got any questions before I stop the video?